Abhilasha Agarwala is going to take us through AKS on Azure Stack HCI. And a little bit later in this session, Nick Wood and Zach Wachtel are going to give us some details as well. So take it away, Abhilasha.
Thank you, Brian. Hey guys, I'm Abhilasha and I'm here with Nick and Zach to talk about our new product, AKS on Azure Stack HCI. As the name suggests, we're all about running AKS in your very own data center. Now, before I start talking about AKS on Azure Stack HCI in earnest, I want to take a couple of minutes to talk about the motivation behind building it. And the simple reason here is people want to use AKS in their data centers. If you have an on-premise infrastructure, I don't need to tell you that not all applications can run on cloud. Many existing applications are simply not connected to Azure, while for many more applications, business needs dictate that they run in their data centers. However, when developers get AKS in their data center, they do not want to lose on AKS consistency, and admins don't want their jobs to get 10 times tougher. We do not do these things. When it comes to the developer, AKS on Azure Stack HCI is consistent with AKS. AKS and AKS HCI share the same upstream code repository and support the same Kubernetes versions. We have also worked on providing an AKS consistent user experience. So if you learn to use AKS first, all those learnings can be applied to AKS HCI and vice versa. When it comes to deploying your applications, AKS HCI supports running Windows and Linux containers in the same workload cluster. Finally, AKS HCI natively integrates with all great Azure technologies like Azure Arc, Azure Monitor, Azure Policy, and many more. Now, when it comes to the administrator, and maybe this also applies to the developer, AKS HCI is a fully inclusive offering that is very easy to deploy. We use deployment tools like Windows Admin Center and PowerShell. So if you're familiar with Windows Server or Azure Stack HCI, you should feel right at home deploying AKS HCI clusters. As I've mentioned before, AKS HCI can run both Linux containers and Windows containers out of the box, and all of this infrastructure is managed for you. All of this also comes with a single support statement and a single vendor to talk to if you encounter any problems or need any assistance. Last but not the least, AKS HCI is secure out of the box, and we manage security for you. AKS HCI also gets to take advantage of all the security investments we made on Azure Stack HCI to make it an incredibly secure platform. Now let me step you through the entire Microsoft hybrid solution. We work with partners for validated OEM hardware that then runs Azure Stack HCI or Windows Server 2019 data center on top. We then have AKS on Azure Stack HCI running in virtual machines that are all automatically updated from Azure and managed for you by Microsoft. You can now run and build apps in your very own data center. On top of this, we have Microsoft first-party offerings running again in AKS HCI. And one of them is Arc for Data Services, which is a container-native data platform that you can use in your applications. This is one of the many upcoming exciting products that Microsoft is working on to strengthen hybrid scenarios for you. Lastly, we provide two management tools to manage all of this: Windows Admin Center and Azure Arc. If you're looking at an on-premises-based management experience, Windows Admin Center is an incredibly lightweight on-premises management tool. If you're looking at managing your resources through Azure, Azure Arc is a single plain control pane for your servers, VMs, and Kubernetes clusters. Now let's try actually deploying AKS on Azure Stack HCI. I have over here a Windows 10 machine with Windows Admin Center installed on it. Let's first start Windows Admin Center. And as I've mentioned before, it's a remote management tool used to manage Azure Stack HCI or Windows Server anywhere at no additional cost. You'll see that I've already added my 2-node Azure Stack HCI cluster to Windows Admin Center. Before logging in to start cluster deployment, let me first sign into Azure. So navigate to Settings. And then as you can see over here, I've already logged into Active Directory. Let me log into my Azure account too by clicking on Sign In. Here, I have multiple accounts, so I need to choose which one to use. And then once it reviews your permissions and I accept it, we're good to go. So I can now navigate back to Windows Admin Center, and I can now log in to my cluster to start a deployment. And you'll see the AKS extension on the left-hand side. Yep, right there. So you can click on Setup, and then you have 5 steps. Step 1 walks you through the prerequisites to get started with the deployment. Here you see a checklist of all the resources you need, both on the Azure Stack HCI that hosts AKS, as well as the Windows 10 machine that runs Windows Admin Center. It also tells you about networking requirements, as well as firewall ports that will be open for deployment. So take a second to just go through this. And once you've confirmed that you have these requirements down, we move to the next step. Here you give WAC access to the AKS HCI cluster so that it can check if the resources that were asked for in the previous page were indeed available. So let's wait a couple seconds. And once it finishes validating the password, yep, it's now checking. And so just briefly going through the checks here. So it looks like I have all the checks satisfied on the Windows Admin Center gateway server, which is the Windows 10 machine. And yep, I have everything running on the Azure Stack HCI node too. Moving on to host configuration, here I need to provide a management cluster name. AKS HCI deployments also require shared cluster volume. WAC looks at all such volumes for you, and then you can select one from the dropdown. This location is used to store the VHDs that will be used for the VMs in the management as well as workload clusters. As you can see on my screen, I've also enabled automatic updates, so Microsoft can manage updates for me. The next step in host configuration is VM networking. Here, you specify the virtual switch used by your VMs, whether you want to tag VMs to a VLAN ID, and if you want to use MAC pools. As for DHCP or static address support, Windows Admin Center currently only supports DHCP. Static IP address is currently in preview only on PowerShell. Finally, you can choose to define a pool of IP addresses apart from DHCP for your load balancer. Now, once you've specified networking and configured storage, we're now ready to move to the next step, which is Azure registration. While this page asks for an Azure subscription, there is no cost for setting it up and using AKS in public preview. After you've made your selections, select Next. Review all your selections so far in the Review plus Create step, and if you're satisfied with what you've selected, select Next to begin host setup. While this is deploying, let's go to Nick and Zach, where they talk about how open source is a core part of AKS on Azure Stack HCI.
Thanks, Abhilasha. Hi, I'm Nick Wood. I'm a principal software engineer and one of the dev architects for the AKS on HCI project. And as we began looking into how we can bring AKS to Azure Stack HCI, one of the challenges we faced was that we didn't have all of the infrastructure that exists inside Azure. We needed to figure out how to bridge the gap and bring similar capabilities to Azure Stack HCI as we have in Azure. So today, while we won't be able to cover all of the building blocks that we've developed, from our Microsoft on-prem cloud stack and cloud SDKs to Kubernetes operators, add-ons, Arc, custom containers for billing, we do want to take a moment to just talk about one area of focus within the project, which was around the deployment and lifecycle operations of the Kubernetes clusters. This starts with our management Kubernetes cluster that we deploy as part of day 0 product installation, and through to the workload clusters that we deploy to host Linux and Windows customer workloads. So as we considered the requirements of the project and the types of day 0 and day 2 operations that we're likely to need to perform on the Kubernetes clusters, we explored a lot of different technologies and solutions. Ultimately, we ended up adopting several open source projects across the HCI product. For example, we've adopted Flannel CNI, HA Proxy, KubeVip, and several other great projects. But one of the projects I do want to take a moment to spotlight is Cluster API. If you aren't familiar with it, Cluster API is an open source project focused on providing a declarative Kubernetes-style API that automates Kubernetes cluster creation, configuration, and management. It's a really cool project. It's one of the key concepts that they bring is that of an infrastructure provider. So essentially, you can, or the various public clouds and on-premise clouds will be able to develop their own infrastructure provider implementation bring it to the Cluster API project, and this code will provide the ability to create networking, storage, and compute resources on the relevant cloud environment. So once you have an infrastructure provider for your cloud, Cluster API can orchestrate calls through that provider implementation and drive the creation of the cloud resources it needs to bring up Kubernetes clusters and to manage them. So to take an example, just to bring up one Kubernetes cluster control node, you would need to, say, perform a sequence of operations on the cloud to potentially create a new resource group, to obtain a load balancer address, create a network adapter, a virtual hard disk, and of course a virtual machine. And inside of that virtual machine, you probably need to do some bootstrapping, like a custom cloud init script, where you can provide the Kubernetes configuration and execute something like kubeadm to initialize the Kubernetes clusters. So pretty much all of that orchestration of that flow is handled by Cluster API. And the implementation of how those computational resources are realized on the cloud and what order they are created is actually handled by the specialized infrastructure provider for the cloud. So as part of this AKS on HCI project, we have developed our own Cluster API infrastructure provider, which calls through our Cloud SDK to the new on-prem cloud stack we've developed, and it orchestrates the creation of resources on the HCI cloud. And this cluster provider runs alongside the core Cluster API pods within our management Kubernetes cluster. And we're developing all this code for AKS HCI in the open. We've open sourced both our Cluster API provider and our Cloud SDK on GitHub, and we've presented our provider to the Cluster API community. This is really important to us. We believe strongly in open source, and we're really excited to be embracing projects such as Cluster API and to be a part of that community. We do see this as a journey, though. We're still exploring, we're learning, and as we gain experience and develop new solutions in this space, we want to be able to share those learnings back and contribute to the communities as much as possible. So with that, I'll hand over to Zach to talk about some of the development work we are doing and the learnings we've had so far that we are hoping to share back to the community in the near future.
Thanks, Nick. To introduce myself, hi, I'm Zach, a software engineer here at Microsoft. I work alongside Nick on AKS on HCI. Our venture into Cluster API and delivering a vendor-managed Kubernetes distribution started with testing out Cluster API v1 Alpha 2. Before I can even get into Cluster API, we had a bigger blocker. Azure Stack HCI doesn't have any ARM infrastructure. To combat this, we had to develop cloud-native friendly agentry to run on our physical hosts. We call this the Microsoft on-prem cloud stack. Getting back to the infrastructure provider model Nick was talking about, we needed to create our own provider, which we would call our on-prem cloud Microsoft APIs. So to bootstrap this provider, we use KubeBuilder. KubeBuilder is a framework for building Kubernetes APIs using custom resource definitions. This allowed us to rapidly develop our infrastructure provider. The controller tools and controller runtime libraries made it seamless to define our own custom resources and then write code that allowed us to reconcile its desired state. Following these patterns and resources used in other Cluster API providers, we were able to get our provider up and running in no time. Next slide. There were a few open design questions we found during this process that made us a little bit different than other providers at the time. First, we had no native load balancing solution on Azure Stack HCI without the inclusion of SDN. We looked towards the open source and developed various integrations with HA Proxy, KeepAliveD, and we're helping to grow communities in newer projects like KubeVip. Second, we didn't have a cloud provider. Kubernetes traditionally had cloud provider code in tree, but lucky for us, there were movements in the community to support external cloud providers, which allowed us to build a custom solution for Azure Stack HCI. After getting past those roadblocks, we had a working Cluster API provider for Azure Stack HCI. Next slide. The next challenge we had was getting from Cluster API running on Azure Stack HCI to a seamless managed Kubernetes experience, such as AKS running on Azure Stack HCI. Luckily, Cluster API is an extensible API that can serve as the building blocks for a managed Kubernetes service on top of it. So from there, we brainstormed how we could create a seamless deployment experience for an Azure Stack HCI user. We went through various iterations of messing around with combinations of temporary bootstrap machines, kind clusters, and interesting cloud init scripts. Eventually, we landed on a method that would allow for us to optimize the deployment process and cut out the need for any bootstrap cluster and only create a management cluster. Once we figured out the flow for the deployment of the management cluster, we had to get to the fun part and figure out how we could easily create target clusters or workload clusters and do day 2 operations. Around this time, Cluster API v1 Alpha 3 was released, and we realized the community had completely rewritten this tool, clusterctl, which is a command line tool that helped the deployment and lifecycle of Cluster API. It also would centralize the process of creating target clusters by providing a method for creating and templating the resources for provisioning a cluster. Next slide, please. We were also tinkering around more of KubeBuilder and CRDs, and watching the success that we have with Cluster API, we were curious what else in our deployments would benefit from an operator-driven approach. Using clusterctl as a backbone, we then created an operator to install and upgrade Cluster API in a declarative model. We called this the cloud operator. We also use this operator to simplify cluster creation UX and to dynamically provision Cluster API custom resources. We also kept Cloud Operator as generic and interface-driven as possible to allow for its code base to be adopted by other Cluster API providers. Finally, we had the control plane layer that we needed to expose to our higher-level callers and users for both the lifecycle of management and target clusters. Next slide, please. One last checkmark that was necessary for AKS and HCI was support for Windows nodes, since we are Microsoft. At the time, there was no support for Windows in Cluster API. So we created a proof of concept in our infrastructure provider to create custom data, which would allow for Windows worker nodes to join the cluster. Once we got that working, we teamed up with the open source friendly folks from Cloudbase, which owns Cloudbase and init. Cloudbase and init allows for Windows guest OS to be provisioned with the same methods as Cloud init. Working with Cloudbase, we were able to figure out a flow that allowed for Windows worker nodes to join the cluster in the same way that Linux worker nodes can. Next slide, please. We have learned a lot with the open source throughout this journey. We have built code on top of and toyed with ideas in Cluster API and we would like to contribute back to the Kubernetes community. In addition to Cluster API, we've also heavily invested in various cluster lifecycle and API machinery projects around it, such as kubeadmin and controller runtime. In V1 Alpha 4, Cluster API will be working officially on bringing support for Windows worker nodes and an operator for Cluster API management cluster. While these features that we already have in production, we realize now that we need to do a better job of developing our solutions in the open from the start to help the strength of the Cluster API project and the cluster lifecycle community around it. Some of the code we developed alongside Cluster API is opinionated to support AKS and HCI, but a lot of it is generic and should be given back to the community. Some improvements we would like to develop with Cluster API and the cluster lifecycle projects are improvements to add-on support, operating system upgrades for machines, optimized management cluster bring-up, and the lessons and learnings from the management cluster operator and Windows node support. The needs and demands of AKS and HCI are growing, as well as the needs and demands for Cluster API, Kubernetes, and the cloud-native communities. The only way to ensure customer success is to be in lockstep with the greater communities to develop high-quality solutions in the open to allow for greater growth. And lastly, last slide. I just want to give a shout out to all these fantastic projects that we've been using and all the developers that have been contributing and maintaining these projects. All right, back to you, Abhilasha.
Thank you, Zach and Nick. It's always amazing to hear about all the work that goes into building a new product. Let's check back on our AKS management cluster deployment. We now have successfully deployed a management cluster in your data center in 45 minutes. How incredible is that? Here, before we go create a workload cluster, you can see that all the packages were first downloaded to the gateway machine, that is the Windows 10 device running Windows Admin Center, and it was then transferred and installed on the Azure Stack HCI nodes. The last item in this workflow was spinning up a management cluster using the installed packages and binaries. Now let's click on Finish. And once you click on Finish, you will be redirected to a lightweight dashboard that contains your deployment details. So here you can see that you can check deployment details such as the Kubernetes version, memory, and Azure details. It's asking me to log in again because of the time lag. Now that you've seen how a management cluster is deployed, let's now use the tool to deploy a Kubernetes workload cluster. Here, let's click on Add Cluster to start a workload cluster deployment. And once the page finishes loading, we can see the prerequisites page again we saw during the management cluster creation. Briefly reading through this, let's now go to basics. Here you see the option to connect your clusters to Azure Arc. Azure Arc extends on-premises resources to Azure, so you can then enjoy Azure services like Monitor on your on-premises Kubernetes cluster. To enable Arc, select a subscription and resource group from the dropdown. You should also have the option to create a new resource group if you choose to do so. You can now provide cluster details like cluster name and Kubernetes version, as well as give Windows Admin Center your login details to start a deployment on your HCI nodes. So just giving in my login details over here. And while the password's getting validated, we support 3 Kubernetes versions right now, and I'm choosing the latest one. And we're now going to configuring the primary node pool. The primary node pool are Linux control plane nodes that will manage your workload cluster. Here, you can enter the number of control plane nodes as well as VM size. However, for public preview in this current release, this option has been disabled. So as soon as the password has finished validating, we will proceed to create user-defined node pools that will actually run your workload applications. So now we can add a node pool here. We can add up to 1 Windows and 1 Linux node pool in public preview, in addition to the system node pool we configured earlier. However, if you've enabled Arc like we did, we need at least 1 Linux node in the Linux node pool for Azure Arc to function. Here, as you can see, you can again select the node size, which is basically the VM size, as well as the node count of your Windows and Linux node pools. So I've selected 1 each with the same default VM size option. I click on Add, and then I can proceed to networking. On the networking page, you can select Advanced if you want to customize the address range used when creating a virtual network for nodes in your cluster. But if you select Basic, then the nodes in the cluster will be created with a default address range. The advanced network settings such as load balancer, network policy, and HTTP application routing currently cannot be changed in this public preview release. On the integrations page, you can connect your cluster with persistent storage. And in public preview, this persistent storage location will default to the storage location selected during setup. We're again reviewing and creating, and once everything looks good, click on Create. So we now saw how to create a workload cluster using the Windows Admin Center tool. Let's now hop over to PowerShell and try a few data scenarios, as well as use open source CLIs like kubectl to manage your Kubernetes clusters. So I'm going to log in to my HCI node, and I'm then going to run a simple kubectl. But before that, actually, let me just start a cluster deployment. So here I've previously downloaded the AKS HCI PowerShell module, and a very simple command where I just have to give in my cluster name should be enough, because the command takes in default values for options that you saw on WAC. So Linux node pools, Windows node pools, as well as VM sizes and node counts, and it starts a deployment. It takes a couple seconds to finish the deployment, and you can see that it's waiting for the control plane to come up and then for the worker nodes to come up before the deployment is in a ready state. While this deployment is getting done, let me just quickly run through what all we're going to do using the PowerShell module. So we're first going to, as you can see on the screen, we're creating a target cluster right now. And we're now going to run get AKS HCI credential, which will put the kubeconfig in the default location that can then be picked up by kubectl commands that we run next. So just running credential with the workload cluster's name. And that's done. So now we should be able to run kubectl to get a list of pods. As you can see over here, there's only one namespace, the default kube system namespace that exists, because we haven't run anything else and we've just created the workload cluster. Now let's try doing something else. So I'm going to try increasing the node count for this cluster from 1 Linux worker node to 2. But before that, let me just show you all the nodes that actually exist right now. So as you can see, we have one Linux control plane node and one Linux worker node that we created. Remember, these were the default values for new AKS HCI cluster. And we can now run the get AKS HCI cluster node count to scale the cluster up to 2 worker nodes. Wait, I think, yeah, I missed the spelling of the cluster name. So let me just correct that. And yeah, this should scale the cluster from 1 node to 2 nodes. And once this command finishes running, I will run kubectl get nodes again, just to show that we have 2 Linux nodes now on our system. So if you run kubectl now, you should get 3 nodes. Yep. So you see this one master still exists, and now we have 2 Linux nodes in our node pool because we just scaled the system up. So these are all demos I had for you today. And we are out of time now. So if anyone has any questions, we're here to answer them in the chat. I do want to take a couple of seconds to point out resources that might help you evaluate our product even more. The first link will help you get started with playing around with AKS HCI. And the second link, you can access documentation to see if it's the right product for you and your organization. For any more details, for any more questions, you can contact me and a couple other folks on our team.
That was a great overview. Thank you, Abhilasha, and also thanks to Zach and Nick. It's great to see some innovations there, and it's also great to see some contributions back to the community. It's always good to share. So thank you very much.